I think that one's too big. Like Walmart, look.
Okay. We got
I'm always at Walmart.
quiet. Sorry for the delay. Okay, quiet. Okay, we're finding a limit as x approaches -2. So you write that down first. Write this on your pink paper. Question? Yeah, I jumped to 7. I do that on purpose because I did 3 and did a video in another period. The concepts are the same concepts. So if we do number 7 together and I make a video of 7, it just gives you more videos to pick from if you ever need future help. So.
Why don't we go -2 if I get -5?
Oh, 2 more for CJ. If I'm finding this limit, what you must keep track of mentally, I'm not going to write it down, but you have to remember that the only way to find this limit is to find these 2 other limits. So mentally we're going to do this, but we're going to save ourselves a little bit of writing, and we won't write it explicitly, but we are thinking of it. And that's always the case. Whenever you find a limit, you must always check the left and the right. Is that what you meant?
Yeah.
Yep. Cool. Okay, x is not approaching infinity, so we don't worry about this step. We do need to look and see if we can factor and divide. And for AP Calculus, they don't give difficult factoring. So the very first thing to look at is simply, can I pull a factor out? And in the numerator here, a 2 can be factored from the numerator. So I write equals, limit, x approaching -2, and I factor a 2 from the numerator. Questions? Yeah, please.
Why are we factoring 2 away from the numerator?
In this case, 3 points for Maddox. My main goal when I factor is to find matching factors in the top and the bottom, which I'm not going to have in this case because there is no 2 on the bottom to factor out. However, I find it somewhat difficult to factor a quadratic that looks like this with a leading coefficient that is not 1. And so if I can get rid of the leading coefficient, it makes the factoring of the quadratic easier. So that's the only reason I pulled out the 2. Okay. Good question. Oh, please, Abby.
How did we know X wasn't going to
Say it loud.
How did we know X wasn't going to
Gotcha. 2 more for Abby. It says to analyze the continuity near x equal -2. So because they asked for that, I'm not going to think about x going to infinity. It doesn't mean x can't. Like this function, they might have an AP question where another part of the question would say find the horizontal asymptote, in which case we would have to think about x approaching positive or negative infinity. Just not in this example. Please.
We have to factor down the x squared plus 2x plus 2.
2 more for Harrison. If we don't factor at this point, I can guarantee we will get the wrong answer. And if it's a multiple choice test, the answer we pick will be one of the valid answers, it'll just be the wrong one. So yeah, we've got to try and factor some more to see if we can get a matching factor. And it just appears that we can because that's a pretty simple quadratic. So I go one more step here. Pull this out of the way. So this is going to equal, limit as x approaches -2. 2 there. find a matching factor. So I'm hoping that this is x plus 2. So without even factoring, that's really my goal. If it's not x plus 2, the factoring is not going to help. So then I think, okay, wait a minute. Yep, that works. If I go x plus 1. Ah. Questions about anything? Oh, please, Nate.
I'm just a little confused on how you got from x squared plus 3x plus 2 to
The factored version.
yeah, to the factor.
Gotcha. There are, every teacher teaches factoring in a different way. For AP Calculus, the following method is, in my opinion, the best. So here's what I would recommend. When you're here and you're not sure how to factor, just stop what you're doing here and kind of somewhere else on some scratch paper off to the side or somewhere, just write down what you're trying to factor. And then write below it this, because they're going to be equal. And then just start asking yourself a series of questions. So Nate, what times what will equal x squared?
X times x.
So that's where we start. Now go all the way to here. You tell me what times what is equal to 2.
1 times 2.
Perfect. So I put a 1 and I put a 2. Now what you're going to do is multiply it out without worrying about any positive or negative. So you're going to say this times this is x squared. And then Nate, this times this is
2x.
Don't put plus or minus, just put 2x. And this is
1x. X.
just an x or 1x, one of the either way. And then this one, Nate. Good. Good to there. Then this, it seems kind of slow, but just so you can see exactly how I'm thinking. Then you say, okay, I've got to get this to match this. So, okay, these two have to add to give me the 3x. Then it has to be plus 2, so that's got to be a plus right there. And then you say, well, this has to match this. So let's see, I've got my x squared. That means this 2x had to be positive. That 1x also had to be positive. That's how I'm thinking.
Okay.
There you go. Cool. If you have any struggle with factoring, keep asking me. It's crucial. They have enough factoring that you got to be able to do it. So, but it's never really anything very complicated. So just keep asking. Okay, cool. Next line is going to say this and break it all up. There's a crucial idea here I want to review really fast. I can't remember if we talked about it or not, but let's talk about it again. That yellow box has 2 values. You must memorize both values. And you have to memorize what causes the yellow box to equal one thing and what causes the yellow box to equal the other thing. So raise your hand if you have any clue what I'm even talking about. There we go. About half of you. Go on, wait a second, more hands. Talk to me, Benny.
If it's a equal 1, like over anything,
Say it louder, Benny. Sorry.
it can be 1 if any value over 0, if x equals 0, then it equals 0, right?
You're super close. No, you're really close. Let me just clarify a little bit. You're really close. If your hand was raised, give yourself 2. Benny gets 3. So the key idea, an example will help. So Benny, if I choose an x that is equal to -2, and I put that x here, what will the top equal, Benny?
0.
Good. If I put negative, so then the negative 2 would have to go in this x as well. And the bottom would equal? Benny? 0. 0 divided by 0 is, Benny? Undefined. Yeah, no worries, that's common. So if you get 0 divided by 0, that's undefined. Question. Let's go, Mariah, please.
Why do you not write the f of x?
Oh, awesome.
The last 3.
Down for here?
Yeah.
Good question. 3 points. So, in reality, I am writing the f of x, Mariah.
Okay.
I'm just writing it in a different way. So at the very beginning, it says, here's f.
Oh, yeah. Okay.
You with me?
Yeah.
I'll just finish now so the video can hear the answer to the question. So these two things are f. On the first line, on the first line, I chose to write this shortened version of f just because I don't need to do anything with it and it's just quicker to write. On the next line, I want to write f again. Here it is. 1 second, Seth. I want to write the f again, but it's now I've got to start doing
Yeah.
stuff with it. Have I answered your question?
Yeah. So you
Seth's got a comment of some sort. I lost you.
I was gonna ask, why would it be undefined if it's a plus 2?
Oh, did I say positive 2? My apologies. Oh, you're talking about the plus 2 here?
Yeah.
So the idea is you're going to plug into this x a negative 2? I may have said positive, that's my bad. Does that answer your question? Please.
Do you have to show it in that steps, or can you do it like if you just split it down to the third step after the first step, or do you have to show like your work and how you got to there?
I think you need to show this step because otherwise it's hard to get to this one. I don't think you have to show the green. Is that what you meant?
Yeah.
2 more for Luke Sperry, yeah. Okay. Anything else?
Oh,
Oh, please.
we have to pull out 2 from x plus 1. Like we can't keep it like blue. Is that what we just asked?
I'll just rephrase. You have to write this so the grader knows what you're doing. You're trying to find the limit of f. You have to write this one because otherwise I think you'll just make a mistake. Then you would write the blue because you're factoring. If you want to stop at the blue, that's fine.
Okay.
I went one further just for kind of better clarification. But I think you can stop at the blue. The grader will be fine with that. 2 more better.
So if we were answering a question, would we need to put a box on x plus 2 over x plus 2?
No, that's just me when I'm talking about it, yeah. 2 more for Matt. Yeah, as I'm doing a video, I tend to circle things over and over again because the video isn't filming me, it's just filming the board. So if I say things like, this changes, like no one knows what I'm talking about, but I keep highlighting what I'm referring to. So. Okay, cool. Erase this. Get back to here. Hey, yellow box. Hands up. Who knows what 2 values the yellow box will have? And what causes the yellow box to have these 2 different values? Let's go, Luke. Roosevelt. The yellow box is always either undefined or 1, nothing else. So one more time, Luke. What causes the yellow box to be undefined?
If it's a negative 2, then it'll equal 0 on both top and bottom. That'll be undefined when it divides by.
Perfect. Sorry to cut you off, my bad. So if you plug in x equal negative 2 for the x's, we'll get 0 divided by 0, which is absolutely undefined. How many knew that? 2 points, 3 first. Please.
Because the limits x to the negative 2, can't you not even plug that in? Is that not even an option?
Hey, listen, hey, you guys are following the discussion really well. If I'm finding a limit, that's not going to happen because the x I'm plugging in is never x equal negative 2. The x is only very, very close to equaling negative 2. So Harrison's dead accurate on that one. So what's the yellow box going to be when we're finding the limit? 1. And then Harrison. So the yellow box is 1. This is 2. What would this equal, Harrison, when x is really, really close to negative 2?
1.
Negative 1.
Negative 1.
So the entire limit would be what, Harrison?
2 times, so negative 2.
Nicely done. And keep in mind that we just found the left and the right limit. 3 more for Harrison. We just found the left-right limit. Like, we did it all mentally, we didn't write it out, but you found the left-right limit, okay? Please, Luke's very.
Why is it -1? Couldn't it be like -1.99, like closer to -2, and then wouldn't that change it?
So if we were truly trying to find XY pairs, and I was going to take, okay, I'm not going to plug in -2, but like you said, I'm going to plug in something extremely close, like, I don't know, -2.01 or something. You are absolutely correct. The result will not be precisely -2. It will be very close, but it would not be precisely -2. But for the limit means figure out what number are we getting infinitesimally close to equaling. And we are getting infinitesimally close to equaling -2. Therefore, the value of the limit is exactly
So when he answered, he'd already added the 1, right? He'd already added the 1 when you answered. That like said -1.
He got the -1 here.
Because he'd already added the 1. It's just a -2. Like,
Right. Yeah, let me say it back just so the video can hear it. So we said, okay, our x is not -2, but our x is close. If I put a -2 here, so I'm close to -2,
I gotcha.
yeah, this whole thing's going to be really close to -1. Not exactly, but it will be really close. Close to -1 multiplied by this exact 2 is going to be close to -2. Mathematically.
Would you need to write equals -2 at the end of all this for the answer?
Right here?
Yeah.
Okay, no one talking. Absolutely. They're asking you to analyze the continuity. A key part of analyzing the continuity is to come up with the limit, the actual value of the limit. Yeah, if you forget to write the -2, you are losing that point. For sure.
So you're multiplying like the first yellow box, like the 2/1 times that one. Is it also times the third one?
It is, but when you multiply, hey, don't talk. Sorry, really, 1 second. When you multiply things together, look at me. Don't double multiply. You don't, like, if you were doing this, say it as a class, please. What is the result of those 3 factors multiplied? Just say it, go.
24.
24. You get that result by like saying 2 times 3 is 6, and the result times 4 is 24. You don't ever double multiply. The same thing's happening here. I have 3 factors. 1, 2, 3. I can multiply them in any order. So I choose, okay, this is really close to -1. Close to -1 times 1 is close to -1. That result times 2 is close to -2.
Yeah, but didn't you plug in -2 to the second one?
We talked about what would happen if we plugged in -2, but we can't do that if it's a limit.
Because it's undefined.
Because limit means figure out what's happening when x is almost -2, not what is happening when x is -2.
Okay, so we just take this second box and like figure out that, like
You do just the second box. It's so close that you just plug it in.
Oh,
It wouldn't matter.
but you don't. Why have you plugged into that third one?
Let me say it one more time. So what I'm really doing is I'm putting into this x and to both of these x's a number that is not -2, but it's really close.
Yeah.
So if you plug in a value that is really close to -2, CJ, what will be the value of this box?
Almost 0.
The top will almost be 0. What will be the bottom?
The same thing.
Same thing. So what will the entire box equal?
Almost. Or no. Oh, okay. It equals 1.
Right, because you've got something really close to 0 divided by the exact same close to 0.
Okay.
So the box will be 1 perfectly if we plug into that x a number that is almost -2.
Okay.
So we leave that alone, it's just 1. what does this box equal when you plug in a number that is almost -2?
-1?
Really close.
Yeah, really.
Fair. So now this whole thing is close to -1 times an exact 2 would be close to -2.
Oh, okay.
That's better. 3 more. Brindley, sorry.
How come you didn't use the 2x squared and the x? How come you took out the 2?
Pull out the 2.
Do you have to?
If I try to find the limit way up here, Brindley's going to get a ticket for this one. Look up. Benny's like, that's my ticket.
It's my question. I asked her. She's like, I asked her. I said, I will. I raised my hand, and she's like, actually, I want the tickets. I haven't really electrician.
I'll give you both the ticket. Look up. Look up. Look up. Look up. Look up. Yeah, look. Here's why. Look. Here's why they're getting a ticket. Here's why you're grateful that they're getting a ticket. Watch. Like, turn up your focus. Look up, Lewis. Look up. Okay. If I try to find the limit, if I'm on the purple line and I just stop there, like I don't go further, or even if I try just way up here, like I don't pull out the 2. Here's what happens. One, the computations are a lot more difficult. Not a lot, but a little bit. Like you take close to -2. I want to give more points out, so you're going to raise your hand. Raise your hand if you can tell me what would be close to -2 squared. Just raise your hand. Come on, come on, come on. What's close to -2 squared? Come on, hands. Lewis, what's close to -2 squared?
-4, sorry.
Yeah, so it's close to 4. How many knew? 0.2 for Lewis. Then you take that times 2. That's going to give you, say it, 8. So that's 8. Then we got to come over here. It's a lot harder for 1. I go 6 times close to -2. So I got 8. 6 times close to -2 is, say it? Good, -12. So 8 plus -12 is -4. But it's just close. It's close to -4. Plus 4 is, say it?
0.
So the top is close to 0. On the bottom, you're going to get negative. That's close to 0 also. Warning. If you are finding a limit and you ever end up with 0, like close to 0, divided by close to 0, you have no idea what you have. Do not pick 0 as the answer. Do not pick undefined as the answer. You should stop and say, wait a minute, I don't know what I have. And that's why we factor. Raise your hand and answer this. Actually, just vote. True, false. 1 second, CJ. This orange formula, is it the exact same formula or is it a different formula than this green mess down here? So vote, true or false. Orange is the same as green, true or false. Show me your vote. Orange is exactly the same as green, true or false. If you're doing this, give yourself 3. Okay? Keep watching. They're exactly the same formula. But up here we end up with, when we try to find the limit, we get we get close to 0 divided by close to 0. We don't know what that is. That doesn't happen on the green. And it's all because of the factoring. So we pulled out the 2 to make the factoring of the quadratic easier. You didn't have to. It just made it easier. But the factoring was essential. Without factoring, there's no way for me to find this answer without a calculator. Does that help a little bit? To answer your question, Billy. Benny, to answer your question.
Yeah. So
Go, please.
one more thing really fast. So when do on equations we like? How do we know whether we should take just like the biggest numbers on both sides, or just do like the whole equation and factor it out? It's just based on that.
Like you're asking, when do you know whether to pull out a number versus when do you know how to factor, like with parentheses?
Yeah. So just pull, like, let's say that's like.
I always pull out a number if I can. It just makes it easier. And then if it's, for our class, I've only seen 2 types of things that you ever have to factor. A quadratic, I guess 3 types. A quadratic, a difference of squares, which is a quadratic. And I have seen things like this before that have to be factored. It was something like 3x squared, I can't remember, plus 6x plus 8 or something. Something like that had to be factored once, but keep going, Ben.
I mean more like the very first day where they just took the biggest values of the very front.
Oh,
That's what I mean. How do you
back up a step. I got you. My bad. What you're mixing up is this idea. If we are finding a limit where x is approaching infinity, I'm not going to factor. I'm going to compare. That's what you're remembering. Fair? And then after I compare, maybe I'll factor, but I'm going to compare first. In this problem, x was approaching a finite value. So I skipped number 1. You cannot compare. Does that help?
Yeah,
Good work.
Thank you.
Southern hands. Here, sorry.
Okay, so like, on every question we do we have to like, are there certain steps that we have to show? Or like, say if we did this question on our own, could we just skip factoring out the 2 and skip straight to what you wrote in blue there? Or do we have to show every single step we do?
Awesome. You have to show the grader that you know, like you have to communicate effectively what you're trying to accomplish.
Okay.
So the yellow box is required. Otherwise, the grader doesn't really know where you're starting. From the yellow, if you want to skip, like if you can do in your head, literally all the way to the green, it's fine. Or if you can go from yellow all the way to blue, totally fine. You don't have to show this at all.
Okay.
Is that kind of your question?
Yeah.
2 more. Please, teacher.
So you said on the top one, you don't know what you have, it's really close to 0.
Over 0.
Over.
Yeah, there's a big difference. Hey, listen, look. If you're doing a limit and the result is close to 0, then the limit is 0. But that's not what happened here. What we got was close to 0 divided by close to 0.
How is it not basically 1 or 1? Because it could be on either side.
The trouble is when we say close to 0, we have no way of computing exactly what that means. So here's a simple example. Just say yes or no, please. As a class, yes or no, would you consider that number close to 0? Say yes or no.
Yes.
Okay, close to 0. Here's another one. Say it as a class. Would you consider that number close to 0? Say it.
Yes.
Good. But the ratio of those two close to 0 numbers is really 100. And that's the problem. When you did your little computations, you had no way of knowing exactly what you had.
Okay.
So when you have close to 0 divided by close to 0, you really don't know what you have. So don't ever just stop and say, okay, wait a minute, I forgot something. And usually what you forgot was you got a factor. Good question. 2 more. Okay, cool. Other questions? This is really good. This whole class, hey, I promise, your success in this class, I'll say it again and again. If you just watch what I do, you will fail the test. Like, it's guaranteed. If you just try to mimic what I do, you'll get tricked. Like, the questions are tricky enough, they'll fool you. You've got to keep saying what you have been saying. Like, I'm complimenting you on the discussion. You just have to keep saying, okay, what about this? What about that? How come you did it this way? Why didn't you do it that way? What was the reason? You have to keep searching for the reasons why I take the steps I take. Please.
So if it was x approaching to like infinity, then you wouldn't even do the factors, you would just compare.
Correct. If I were trying to figure out whether this function had a horizontal asymptote or not, I would have started completely differently. I would have started here, 2 more for Annie, and said, hey, I've got to find out what happens when x gets really big. So I need to compare now. Okay, cool. We're not done. We found the limit. It asked us to analyze the continuity. So we have 2 more little things to do. One, pull this stuff out of the way here so we get some room. Erase this. We need to find the value of the function at precisely x equals -2. Raise your hand, don't say it out loud, please. What would I write after this? Hands up. I was hoping for more and quicker, but that's okay. This is called learning, so it's all right. Got about a third of you. Let's go, Eli. So Eli comes back to my green formula, which is my favorite version of the formula. And he just remembers what we already talked about. If the x is precisely -2, what does this equal, Eli?
0 divided by 0.
Which is? Yeah, 0 divided by 0 is undefined. close to 0 divided by close to 0 is we don't know. There's a difference, and they're both I don't know, but one is a certainly I don't know. The other is like, that's a terrible discussion, really don't know. Please.
What's the difference between undefined and does not exist?
For the purposes of our class, they'll use the word does not exist whenever you're talking about a limit. When you're talking about a function's value, then we use the word undefined. Other than that, I don't know that there's a huge difference. Please.
So because we're plugging in -2, the other two numbers, factors in that don't matter?
Yeah, think of it this way. Undefined is a fancy way of saying we have no way of knowing what it is. So undefined times something we know is still we don't know. And we don't know times something we know is still I don't know. So definitely undefined. Two more from Michael. This must be why people say this isn't math. Like, all we talk about is like we don't know. So, questions? Yeah, please.
So where was the limit to negative? Like you did almost negative, but then it's not after negative.
Correct. Hey, 3 for Lindsay. In this case, x is precisely equal to -2. In the limiting case, x is not ever equal to -2. That's the huge difference. Please, Michael.
What does this graph look like?
So this one would look like, hold on a second. Let's see if I have a picture of it. Looks like that one.
Oh, so it's just a line with a hole in it?
Except for AP tests, don't call it a hole. They don't use that word. This one's not a jump either because the limits on left and right are the same. So it's a removable. So here's your conclusion. One second, Ellie. So here's your conclusion. There's the work and there's the conclusion. Ellie, please.
Can you just explain how you got undefined one more time?
Huh? So are you comfortable, Ellie, that F is really just a formula that finds x, y pairs? Awesome. Are you comfortable that the orange formula and the green are identical?
Yes.
So I'm going to use the green to find the y value when the x value is -2. So I start here. What will this equal if x is exactly -2?
0.
And this would be?
Same thing.
So this whole thing would be, when x is -2, it's undefined. Yeah, it's not 1, it's undefined. Undefined multiplied by whatever else would still be undefined. So that's where this came from. Did that help?
Yes.
2 more. Buddy? Please, CJ.
You have to write, like on the calc test, you have to write it with like the however undefined therefore, like that's how you do it.
If they say, use limits to analyze or to show, you have to. Like, they will absolutely not give you points unless you write this.
Oh.
Because that's the definition.
Yeah.
That's a good question. 2 more, but you have to. Please, Nate.
But say like you use different wordings, like you say, since the limit of x going towards -2 doesn't equal f of -2, f of x has a removable discontinuity.
Perfect. Yeah, that's fine.
That works too.
Oh, yeah. You can use different wording. Key things are, they've got to see somewhere that you found the limit. You've got to show enough steps so they can see your logical method of finding the limit. You've got to state this definition somehow. And you got to state this. Yeah. But you can use different words. You can rearrange it. You can say one before the other. Like I could say, whatever. You've got the idea. 2 more, please, Jake.
Why are we not finding the left and right side? Why are we just saying?
Awesome. Hey, look up. Look at me, everybody, look. 3 for Jake. We actually did find the left and right. I just made the assumption that you would all prefer to write fewer things and do more in your head. So when we got to here, every time you see a limit, you have to be thinking left and right. Always, no exception. But I just did it mentally. I said, well, If the x is almost negative 2, this will equal 1. It won't matter if the x is a little more or a little less, it will still equal 1. Comfortable?
Yeah.
If x is almost negative 2, this will be very close to negative 1 in either case. So I've verified that the left and the right are giving the same result, but I'm always checking the left and the right.
How is that checking both sides?
So are you comfortable that this is always going to be 1 either way?
Yeah.
So right here, if you had like negative 1.999999999 plus 1, it's pretty close to negative 1.
Oh, okay.
If I had negative 2.000001 plus 1, hey, that's still close to negative 1. So
Okay.
both ways work. 2 more. Other questions here before I stop the video? Perfect. Stop the video.